Process and Equipment, ECMs. Common Energy Conservation Measures, or ECMs. Let us review process options as they pertain to what we have discussed. Screening. This is typically a low energy user because it usually uses small horsepower motors. But looking at the process side of the operation, this is an option. Look at the control strategy. The screen start and stop cycle. Can it be adjusted to limit the runtime? There are treatment plants that run the screens 24 hours a day. Maybe they should have time control or differential controls. Influent pumping. Remember the impact of pressure on pumping cost. Can the wet well operating level be adjusted to reduce the pumping head? Just a small decrease in pressure or head can save 2 to 4% or more in energy. Grit. If we have an aerated grit chamber, change the blower sheaves to reduce the air volume and power use, or consider short run time cycles. Remember, we are trying to create a rolling action, not aerate the contents to get a dissolved oxygen. We do not want to be blasting a lot of air that really is not necessary. If there is a pump system for removing the grit, can the runtime cycle for removal be adjusted? With primary sedimentation, the goal is to remove as many solids as possible, as this will reduce the load on the aeration tank and associated running of the process blower. Sludge and scum pumping are the largest users of power in primary, so look for opportunities to optimize the pump cycles. As far as secondary treatment is concerned, aerated tanks are a must. Therefore, blower use is high energy. Inlet vanes or valves are typically used to control airflow rates. Options to consider include dissolved oxygen probes and DO control. Consider the use of fine bubble diffusers to get better oxygen transfer. Another parameter to consider is pressure control on the air header, since we know now higher pressure costs energy. A new turbine type of blower is now being used that is more efficient than your standard centrifugal blower. Plus, it is more suitable to using a VFD. This will improve our ability to deliver the right amount of air. Common ECMs. Another process-related energy conservation measure includes the return activated sludge pumping. This process involves being able to pump a volume equal to 40 to 100% of total forward flow. We may want to consider time cycles. Most of the time, many systems already have VFD control, so it may be a matter of maintaining a certain blanket depth. Consider time cycles, but cautiously, so we do not impact the process itself. Time cycles are not appropriate with a single pump and clarifier, but are an option with multiple systems. This way, sludge can be continuously returned to the process. Waste activated sludge, or WAS, pumping is usually a small percentage of the flow. Normally, WAS is approximately 1% to 3% of treatment plant influent flow. Generally speaking, with WAS, we want it to be as thick as possible to avoid sending too much liquid volume to the sludge handling system. Disinfection is a low use, but high energy to produce hypochlorite, or if you are using ultraviolet or UV light, you may have high energy use. With UV, it is about process efficiency, so maintenance of the bulbs and tubes are critical. As far as filtration, most energy use is in the backwashing, especially if it also uses an air scour. The backwash process is the perfect opportunity to do off-peak operation if that is part of the tariff. As far as process options for sludge thickening, gravity thickening, rotary drums, and belt thickeners, These processes are usually low energy consumers. There is not a lot to find in savings here. Sludge stabilization. If using aerobic digestion, it is usually a high energy user. As mentioned earlier, an option is to consider on and off cycles for the air system. This option will also improve the process by reducing the nitrate concentration in the decant liquid. Anaerobic digestion is typically a producer of energy. It only uses energy when mixing, which the process requires. Consider mixing intermittently or interim operation of heater recirculation pumps. Mix and recirculate during off-peak hours. When sludge dewatering uses belt presses, it is preferred as they are low energy users. Centrifuges are high energy users, but they can produce a drier cake. Filter presses use moderate amounts of energy and produce a drier cake as well. Drier cake is the goal here, because we do not want to pay for the disposal of liquid. Some additional process ECM options for pumping includes varying the return sludge pump speed to correspond with rising or falling sludge blanket levels. Blanket detectors have become more reliable, and this is a good control strategy for RAS control. Another option is to operate the return sludge pump in on and off cycles. We want to be careful with this option as it can create problems in the sludge quality. We can especially do this at nighttime when flows are low to start with and we are typically slowing down the pump considerably. If we have multiple pumps, give more runtime to most efficient pump. Or if there are large pumps, consider having a smaller pump to handle the lower flow periods. Increase the wet well level or reduce pumping head, and if you can, add VFDs. Again, not as something that is going to necessarily have to pay for itself, but we can do it as an upgrade. Use timers for on and off operations. Reduce recycle flows such as filter backwash, foam sprays, etc. Flush the lines periodically to remove any accumulations that could be creating head in the lines and trim the impellers. When it comes to activated sludge systems, ECM options for DO control includes on and off timer control for blowers or air drops valves, diffuser cleaning and bumping the diffusers, converting from coarse bubble to fine bubble diffusers, lowering the DO set point, adjusting the air drop valves. Maybe we do not have a way of controlling each air drop, but we can adjust the air valves going to the air drop. Putting DO sensors in the correct locations. Reducing the number of aeration basins in service, especially if we have multiple trains available. Maybe we do not need to have air going to all of them. Reducing the pounds of solids under aeration, but do not reduce the pounds of solids to the point where it impacts BOD, ammonia and nitrate removal. Looking for boils or unusual bubble patterns in your reactors or aerated zones, and replacing or clean fine bubble diffusers. A membrane type of diffuser is typically replaced every 5 to 7 years. For blower systems, make sure leaks are repaired, and typical O and M tasks such as cleaning the filters and bearing lubrication are performed. The blower intake uses outside air versus room air. Is it possible to use inside air since it should be a clean source? Clean and check the DO sensor periodically. A lot of places have a laboratory instrument that they use for calibration checks of their field instruments periodically. Reduce the air header pressure by better control of the airflow rates and balance airflow rates to meet the needs of a specific zone. Use adjustable speed blowers. Consider a new technology that uses turbo blowers, which are more suitable for VFD control. Reduce airflow where possible and only use one blower if it can handle the demand. Benefits of high efficiency blowers. Remember that aeration is the biggest part of the energy costs at our plants. This slide reinforces the fact that energy consumption accounts for 75% of the cost associated with the blowers. That is a great opportunity to reduce energy costs. The turbine-style blowers offer greater efficiency and the ability to turn down airflow rates over a larger range without the worry of blower surge. Looking at the mechanical mixers, we want to make sure that the submergence depth is what is recommended. Perform the operation and maintenance checks and include checking for accumulations on the mixer. Anything running around in circles with that mixer is probably causing extra energy consumption by creating drag. Reduce the number of mixers if possible. Consider not mixing in the pumped recycled zone. Again, that is another case where we look at the nitrate recycle zone, and since we have pumped recycle going to this zone, maybe it is not necessary to also run a mixer in this zone. Other systems. Discussing other systems, for ventilation and odor control, we should ask, can airflow be reduced and still scrub the air? Or can the system only be run seasonally when odors are worst? Run certain ventilation equipment in on and off time cycles. With ultraviolet disinfection systems, keep the lamps clean, remove scaling buildup from the tubes, and replace lamps with high output lamps. For lighting systems, remember to turn off unneeded lights. Use occupancy sensors, and switch bulbs to the T5 or LED type. For the laboratory equipment, do we have a muffle furnace we are leaving on all day long when we may only be using it for a test once or twice a week? Building HVAC systems. In building HVAC systems, ECMs to consider include questioning if area heat or air conditioning systems can be used only when people are working in the area. Look for the low-hanging fruit with HVAC systems. We are all guilty of running HVAC equipment because it is there, not necessarily because we need it. Thinking about energy, if a 5 kilowatt unit is running constantly, it is costing a 5 kilowatt demand plus energy consumption at that rate for every hour it is running. Other options typically used includes cleaning or replacing air filters, tuning units for maximum efficiency, using automatic thermostats, or using timers or occupancy sensors, etc. Another new concept may be, can we take heat from the blower room so it can be directed to other areas? You know the blower room is probably the hottest place in the plant. Can we use that heat somewhere else? Plant process control systems. Many of the newer systems use graphic screens similar to this to show power data on a continuous basis. With this graphic page, we see the total plant power data including amps and volts. This is another screen of a control system. It provides kilowatt demand data and power. So again, screens like this may help us visually see what our system or a piece of equipment is doing. Monitor a screen like this to see changes in kW when equipment is either started or stopped. Last but not least, this booklet is an EPA document that is available for your use. It provides you guidance to help set up an energy conservation program and is included in your course materials.